Hey there, I'm Chris Kroll, editor-in-chief of Solar Builder magazine, and I'm here with Douglas Amarhanow from FranklinWH, and we're here to discuss our vehicle-to-load playbook that we published earlier this year. So that was the impetus for doing this special report, is explaining the current pathways to easily have a customer with an EV use that EV to back up their home in the simplest way possible. So I have Doug up here because he's an expert in this, and we want to kind of go through the report during this chat. So, Doug, I wanted you to start by explaining maybe the terminology, because I see vehicle to load and vehicle to home thrown around. What would be the differences in those two terms?
Great. Thanks, Chris. Appreciate that intro, and looking forward to speaking with you guys today about the V2L and the V2H topic. I actually want to step back for a moment and talk about why we need an EMS, which is known as an energy management system in your home. And high quality EMS is going to make sure that you meet all your goals with your products, and whether that's going to be backup power for resiliency or economic reasons for time of use, or to minimize your utility bills through self-consumption. So vehicle to load, the EV is a great asset in your home, and you want to make sure that you can use that asset. It's probably a huge battery. We have a battery here. It's called the A-Power. It's about 15 kilowatt hours. That EV may be anywhere between 50 and 100 kilowatt hours. So multiples larger than your home battery. And it makes sense why a homeowner would want to be able to tap into that for resiliency purposes, and potentially even to earn extra money for their utility bill.
Yeah, so what equipment does a customer need to enable, if they have an EV that has the capability to kind of go into generator mode and back up the home, what else do they need to enable that in the simplest way?
Cool. Yeah, so in order to be able to utilize that EV to provide the power to the home, you would need, you can actually pursue a couple different avenues. You can use a DC coupled connection, which is potentially to bring the DC power from the battery pack in the EV out to a inverter, which is hung on the wall, to the home and converted to AC for use in the home. That's one pathway. It's a little bit more complicated. It's going to cost a little bit extra money. Here at Franklin, we like to keep things as simple as possible and rely on AC coupling. Because AC power is what's used in the home. All your loads are AC, even though your end use for that load may be a DC charge to your phone. AC usage is simplest. So that's why we're pursuing using the AC power that's available in the car, specifically some of these larger trucks where you have the generator port in the car, and being able to take that directly from that generator port and bringing it to the home loads that way.
Gotcha. And in our report here, there's a quote that you have about there needs to be a handshake between the EMS and the EV. I guess what do you mean by that?
Yeah, the handshake is important because if we're using this for resiliency purposes, you want to be safety first. Actually, safety first for everything, basically, right? And you need to make sure that you're safely islanded from the grid. If the grid is down and you're not feeding power back out to the grid, you don't want to electrocute any line workers, and then you can safely use power actively in your home. Once you have the handshake, you confirm that you're islanded.
Gotcha. So if I'm a homeowner, I have an EV, I have the ability to do what we just discussed, why would I need energy storage in addition to the EV as my home backup?
Oh yeah, so once you get an EV, your utility is very fearful of this EV because you could potentially be drawing another 50 amps, and conservative utilities may require you to, their worst nightmare is for you to charge that EV on the hottest day of the year, and so they're going to have to build out transmission or distribution and put in a new gas plant for your EV.
Yeah.
So most likely you'll be pushed to a time of use tariff to help incentivize you to not charge the EV during the hottest day of the year, during that evening peak period. So they'll incentivize you with hopefully cheaper electricity to charge an EV during the nighttime. Um, in concept, you could use that EV to help offset your time of use load at your home as well. But in reality, you're probably going to want to have a home battery to help offset your usage during that peak period to make sure that you're getting the best bang for your buck and not drawing power from the grid during that expensive period from 4 p.m. to 9 p.m. typically.
Yeah, it makes sense. So so when you're pairing an A gate with an A power with an EV on that different time of use rate, you have a lot more flexibility and options to make your electric bill kind of as low as possible and kind of manage it dynamically. Could you maybe give an example of how the A gate functions with that ecosystem of loads and that you're trying to manage all at once?
Yeah, for sure. So I guess we can just walk through the basic product functionality on a regular hot day, right? So your A gate is there. It has the CTs, which are built in to measure the grid draw. And if you're in this time of use tariff, it's basically a self-consumption during that peak period. And you're going to be metering the loads, whether it's whatever you have going on in your home, you're going to be drawing power. You're going to first use solar if you have it, if it's available, to help offset the loads because that's the cheapest possible power. Then you'll probably use your home battery as a secondary, and then also use the EV as like a tertiary to help offset that load. All well and dandy. Not sure if that's going to be what's available in your home. Your car may not be home. But that is what we're going to roll with in concept.
Yeah. Well, and then, so going back to the idea of using the EV as home backup, I guess what should people know about the differences in a normal standby home energy storage system battery versus an EV battery, and how they perform and how the EV battery, what its limitations might be, or just how it can be used in that application?
Yeah, so your home battery, the Franklin battery, I can definitely speak to that. I don't know about all other home batteries. It's the Franklin battery is basically utility grade storage for your home, and so that's really designed to discharge on a daily basis at 10 kW or whatever other nameplate power the inverter will have in the future, and to fully discharge. And that's kind of like a tough cycle that the EV car is probably not built for, right? And people rarely drive their EVs 300 miles a day and cycle the battery fully. So it's a different chemistry, it's a different use case. The EV is typically, it's built for that acceleration away from the stoplight to accelerate away on the merging lane in the highway, and then also, that's like a 4-ton vehicle, maybe a 2-ton vehicle, and you have a 100 kW inverter. It's really built for that inrush in terms of the cells. The chemistry is optimized for it, and so even down to the chemistry level, those cells are going to be different from the storage in your home. And so you may not want to use that EV on a daily basis to cycle it to power your home. It's kind of like a different use case. I understand that EV batteries have gotten quite a bit better in the past few years, and so even with these worst case scenarios where they're being cycled, these battery cells are being cycled every day, they far outlast, and their degradation is like nowhere near the expected rate.
Yeah. So how might that impact the EV battery warranty even if you're just doing the kind of backup scenario? Maybe forget time of use, but do they say anything in the terms of?
Yeah. So I just want to start off by saying I'm not
I know you love this question.
I don't work at the EV manufacturer, so I can't say it with 100%. But if you check out the warranties on their website, all their warranties are focused around like 10 years, 100,000 miles, or 5 years, 50,000 miles. It's the traditional car warranty that people are used to. And they don't say anything about utilizing the AC power coming out of the car on that warranty. So, if it's not there, then it's probably okay. Those legal guys are word things very deliberately, and you can assume that the drawing power from the EV is such like such a low impact event on the car rather than like accelerating away from the stoplight or bringing that car or driving the car 50 miles on your daily commute.
Yeah, right. Um, so, well, my next question here was actually about the why AC coupling and EMS, why that's important in what we were talking about. You touched on it a little bit already, but it is a part of your bread and butter pitch here at Franklin. So maybe let's discuss why AC coupling you feel is important. I guess beyond why the product offering, why it's technically the way to go in your mind.
Yeah, so here at Franklin, FranklinWH, we really cannot stop talking about the versatility and the simplicity of AC coupling, because your home has been designed to use AC power for the past 150 years, L1 and L2, and everything's built around that. All the electricians understand that, and so it's probably the simplest and most affordable way to integrate things to your home in terms of power. AC coupling is, it's future-proof because you can continue to add different pieces of the ecosystem to the system without having to worry about spec comparison, making sure that your DC voltages are lined up, yada yada. It's definitely the easiest way to go. And then that allows you to bring other elements into the ecosystem, third-party elements such as an additional inverter or a different smart panel or I guess even an additional EV, whether that's going to be another power source or load.
Yeah, that's a great point and a good transition into kind of the last part of our conversation here about vehicle to grid if that time arises, right? Because having a system installed at the beginning that allows for that flexibility in multiple directions in terms of adding new sources, new loads, and then maybe being able to function on the grid is important. Now you can kind of do all of that today, it sounds like, if you install the right system at the beginning.
Yeah, absolutely. So, bringing it all back to AC coupling, this is what the home's used to using, but also what the utilities used to supplying you with. So there's this whole ecosystem of standards built up between UL and IEEE and basically everything else to regulate and to I guess ensure that there's high quality power coming into your home being supplied to loads. Whether that's going to be from the EV or from the grid, it's kind of all the same thing. Want to make sure that we're following the IEEE standard 1547. Currently it's 2018. I know everybody's working on the 2026 standard, that edition, and we see different regulations and different, I guess, definitions being supplied there and developed. And we want to be available. Anything that comes down the road will be kind of future-proof and being able to integrate because it's all AC coupled. And yeah.
Yeah, and in the report here, we note that vehicle to grid and virtual power plant programs that use EVs they've started, but they're in their early forms. Like some examples here, in Connecticut, there's the Energy Storage Solutions. California has DSGS. Idaho, Utah, Wyoming have WattSmart through Rocky Mountain Power. North Carolina has PowerPair. Vermont has Bring Your Own Device. So these are happening, and FranklinWH is up and running in these programs. Do you get a sense that we are at a tipping point and going to be seeing more of these, or are we still kind of in a middle ground, kind of waiting for vehicle to grid to get to the next level of impact?
Yeah, I absolutely do think that we're going to see more VPPs or demand response programs for both the EV and the home battery in the very near future. Every day we hear more and more about these AI data centers that are coming to take all your power, but are also going to push the grid to its limits and to limits that it has never seen before since it was built in like the 1930s, right? So these AI data centers and everything else that we're adding to the grid will definitely demand that the utilities become less conservative with their sizing and more adaptive to the software solutions that are out there. It is 2025 after all. There's more technology than we all yeah, this stuff's developing really fast.
Yeah.
So definitely expect more programs to become available in the future. These VPP programs that you listed have been around for 5, potentially even 10 years now, and the utilities are becoming familiar with how to actually rely on that capacity rather than just thinking that it's not going to be available when you need it. These batteries and then the EVs do show up, and the power electronics and the EMS have become extremely reliable. So you can definitely bank on that to supply your large loads when you need it to.
Yeah, and I think that's the note to end on is the technology is here now to be ready for whenever a VPP program ramps up in your area. The V2G story is basically waiting for utilities to kind of implement, waiting for automakers to get on the same page with utilities, and there's a lot of interplay, and that's what's kind of holding it back. But it's not a technology issue, really. We kind of have the inverter standards have been set for grid interactivity, and with an EMS like the one that FranklinWH provides, if you install that, you're kind of ready for whatever happens, and that's kind of the point of our report here. And if you want to take a look and are tired of us rather read rather than listen, this report is available in our issue that's here at the show, the Q3 issue of Solar Builder. It's also online. You can go to solarbuildermag.com, download it, share it with your friends. So I think we about covered it, Doug. Is there anything else you wanted to mention before I let you go?
Yeah, did we talk about EMS or AC coupling yet?
I don't recall.
Yeah.
I love it.
Cool.
Okay.
Well, definitely appreciate your time, Chris, and hopefully we can, we definitely get the question about how the homeowner can use their EV in their home energy system at least once a day. It's probably one of the top 3 questions that we receive, and hopefully this little segment that we posted will be able to help guide homeowners on that, and then also understand that it's definitely a developing scene, and want to know that this solution that we have now will be able to support their needs in the future.
Absolutely. Thank you, Doug.